Hello, Math 1430 class. Today I'm going to cover section 5.4, and that section is called Derivatives of Exponential Functions. So exponential functions have a constant base and a variable exponent, and we're only going to look at exponential functions where the base is e. So I want to go over these four questions. So we're going to differentiate. That means find the derivative of this function, f of x equals 3e to the negative 2x, which has a constant factor 3 in front. And then we're going to take a look at f of x equals x cubed times e to the 5x. So notice this e to the 5x, this is an exponential function. The base is a constant and the exponent as a variable. This x cubed, by the way, is not an exponential function because the base is a variable, but the exponent is a constant. So this factor is a polynomial factor multiplied by an exponential factor. Very interesting. Okay, so that means we can use the power rule for derivatives just with the x cubed, because power rules for derivatives are when you have a power that's constant, a number. Here you cannot use the power rule. Don't think about bringing down the 5x times e to the 4x. That would be totally wrong. Totally. Okay, and then we got another function, which is a quotient. So we're going to use the quotient rule to find the derivative. And here's the final one, which is a fun one. It looks scary, but in fact, it is the easiest one on the board. So we want to find the derivative of f of x equals pi to the e. Well, pi is just a constant, and e is just a constant. These are probably the two most famous irrational numbers. It's roughly 3.14 to the 2.7. So what is the derivative of a constant raised to a constant? Well, first of all, a constant raised to a constant is just a constant. So what's the derivative of a constant? 0. So that is the answer for the last problem. I'm going to grab a pen here and write 0 for this answer. So if f of x equals pi raised to the e, I'm going to write f prime of x is equal to 0. How about that? Because the derivative of a constant is 0. That was a trick question. Okay, so let's go to the top one. F of x equals this. So if I want to find the derivative, make sure you write f prime of x equals, and now this is a constant factor, so I'm allowed to pull that constant factor out and then multiply it by the derivative of e to the negative 2x. So the derivative of e to a power is exactly what you see, e to the power. And then by the chain rule, we're going to multiply it by the derivative of the power. The derivative of negative 2x is negative 2. So that's our first step. So remember, the derivative of e to a power is exactly what you see, e to the power, and then by the chain rule, times the derivative of the power. And then you want to simplify this. So I'm just going to write equals, and I know 3 times negative 2 is a negative 6, and then write that factor of e to the negative 2x. And I would leave your answer just like that. That's good enough. You don't have to write this as 1 over e to the 2x, and then that's going to equal negative 6 over e to the 2x. This is all they want, just like that. It's okay to have negative exponents in your answer. Okay, so that was our first one. Here's our second problem. I see a product, so to find the derivative, f prime of x, I'm going to use the product rule. So the way I do the product rule is I go the first times the derivative of the second plus the second times the derivative of the first. And there's like 8 variations to this product rule. So you can do it slightly differently as long as you get the same answer. Okay, so here I go. The first times the derivative of e to the 5x is e to the 5x times the derivative of the power, which is 5, plus, so we just did the first times the derivative of the second plus the second, and here comes my brother, he's going to tape me. Hello, class. Okay, so I got this. Let me go over here. Okay, and then we're going to go plus the second e to the 5x times the derivative of the first. So the derivative of the first is by the power rule 3x squared. By the power rule. So first times derivative of the second plus second factor times the derivative of the first factor. And then let's simplify that. That's going to equal, put the number in front, the constant factor. So it looks better if you write it like this. 5x cubed e to the 5x. That's the first term simplified. Plus, and then put this number in front. To be consistent, I'll write the x's and then the e like I did before, but that doesn't matter so much. So 3x squared e to the 5x. And these are not like terms. This is called an x cubed e to the 5x term, which is different from an x squared e to the 5x term. So you cannot add these as they are. So let's just box that as our final answer. So to find the derivative, we use the product rule. Okay, and then my last problem. To find the derivative of this quotient, we're going to use the quotient rule. So f prime of x is equal to, and here's the quotient rule. It's low d high minus high d low all over low squared. That's the way I do it. In words, it's denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator square. Don't forget that part. So here we go. It's going to be the low times the derivative of the numerator. What's the derivative of e to the x? Itself. Because notice the derivative of the power is just 1. Times 1 I don't have to write. So that's kind of cool. E to the x is its own derivative. So there's low d high minus high, which is the numerator, d low. So times, what's the derivative of x to the 4th? 4x to the 3rd by the power rule. So it's low d high minus high d low all over low squared. And then let's simplify this. So in the numerator, I got these two factors. So let's simplify that. Actually, we really can't. So just write x to the 4th e to the x minus, and I'm going to write the 4x cubed first. It looks nicer, I think, that way. Times e to the x all over. Power to a power you multiply. 4 times 2 is 8. Ocho. So this looks like a pretty good final answer, but it's nice to know how to factor out GCFs. So in this numerator, I've got two terms. Notice, by the way, quotient rule has a minus sign, whereas when you do the product rule, you have a plus sign. So try to remember those rules. So what's the GCF of, I only have two terms in the numerator, this term and this term. So I see an x to the 4th, and here I see an x cubed. So the greatest common factor, you always choose the lower exponent. E to the x is in both terms, so pull that out. And then what am I left with for the first term in the numerator? I only pulled out 3 x's. I need one more x. And that's good for the first term, minus, and then I'm missing just a 4. Everything else looks good. All over x to the 8th. Done! Done! You could cancel the x cubed with the x to the 8th. Oh yeah, actually that's a good idea, Brother Doug. Yeah, so this is not quite done, because these are all factors, so I can simplify. X cubed over x to the 8th is going to be 1 over x to the 5th. Because think of this as x times x times x, and the denominator has 8 factors of x. So when I cancel out 3 of them with 3 of them, I'm left with 5 factors of x downstairs. So my final answer, it's always nice to be neat here. Let's write e to the x over x minus 4, or I'm sorry, e to the x times x minus 4, all over x to the 5th. And that is the final answer. And by the way, I just want to say, overall, Test 2 went pretty darn well for Math 1430 classes. So obviously not everyone did well, but as a class, Good job. Good job. So let's finish strong. This semester is winding down before you know it. And how about that snow? It's a winter wonderland outside. All right. Good night, everyone.